This recording we will be covering two ideas about similarity measures, and most importantly we will be covering the idea of standardization and normalization of the dataset or of the variables. So first we have an example here. We have a dataset containing starting salaries of newly hired employees in dozens, and we have their GPAs. We have only 11 of these employees. So first we would like to find the z-scores, standardized value and normalized values for the salary and the GPA. Then compute the Euclidean and Manhattan distances for all possible pairs of the employees to look at the similarities, who are similars, who are dissimilars. We will be discussing the impact that standardization has on the similarity distances. So first we are going to load the data, load the library and data. And let's look at the data. We have two variables. We have the salary and we have GPAs. By the way, because we have two different scales, it's advised to standardize the data or normalize them. After that, we are going to calculate the Euclidean distance. So we are going to use a function called dist. This function dist contains only two arguments, which is easy. So dist what? My data. And what is the method we are going to use? Because we said dist contains two arguments, at least, where we're going to use my data and the method. What is the method? We're going to use the method. The name of the method is going to be Euclidean. So this is the dist. So if I run this, so I'm going to get Euclidean distances between observation 1 and 2, 1, 3, 1, 4, 1, 5, etc. So if you have many observations, you will see them that way. It's like in a matrix way. I'm not going to go deep into this. This is just enough for us for now. You can give it a name, by the way. You can give this one a name, Euclidean dis. Also, if you'd like to round the numbers, we can do round. We can add round function at the beginning, open parentheses, go to the end, add another argument, which is I need to round to the nearest 2 digits. Then you can run again. So we have 2 digits now. It makes more sense than before. So I'm going to repeat this and calculate the Manhattan distances. So I'm going to copy this, paste, just change the name, Manhattan dist, right? I'm going to keep the round, keep the distance function, the distribution function. Actually, it's not distribution, it's distance. It's distance function, it's not distribution. It's my bad. So this is the distance function. Distance function, my data. The method I'm going to use, not Euclidean now, I'm going to use Manhattan. Keep the round, then enter these. What happened? These are the Manhattan distances. You can compare both and get some insights. But the more important idea, which is we'd like to know or how to do, is standardizing both variables. So we are going to use a scale function. We're going to use a scale function and scale, just simple scale, just to scale my data, scale the salary. Also, I would like to scale the second variable. If you scale it, these are what we are getting. We're getting like a matrix form. So this is a matrix form, okay? Matrix form. So what we are going to do, we're going to change this scale to vector. Why we are going to do this? If you'd like to the standardized value, this is the scaled value, this is the z value, this is the standardized z. If you'd like to add it to my data as a new column, I can do this. I can do my data, I can add z salary. So I am adding a new column called z standardized salary to the my data. If you run this, if you go to my data, you can see that this is referred to as a matrix because we have look at this format. That means we are adding like a matrix to a data frame. This doesn't make sense. You can add vectors to the data frame. Let me change this to be vector, okay? So I'm going to add only as vector before this, close the parentheses, and we're done. Go here, close it, run my data, here we go, salary. Now we are adding vectors, so we have a full data frame. We can repeat the steps here for the other variable, which is what? Z, GPA, right? So I'm scaling the GPA, standardizing the GPA, I'm changing the GPA as a vector, then I am adding this, stacking this to my data frame, right? This is the Z GPA. Also, we can do the normalization technique. You can use the normalization technique. Normalization, we're going to use a formula, right? My data, we're going to add another column called normalized, normal salary. What is the formula of the normalization? We take the salary, then we subtract it, we take each observation, and we subtract the minimum, then we divide by the range. The range is the max minus the minimum. This is the formula. It's from the book. Go back to the slides or the recording we did about the similarity measures. So first, because we have a numerator denominator, I'm going to use parentheses here, okay? This is for the numerator. divided, this is for the denominator, numerator. I'm gonna do my data salary, subtract the minimum, min function, my data salary. So I'm subtracting every observation, the minimum from every observation of the salary, then the range is max minus the minimum, my data salary minus minimum of my data salary. Run this, go to my data. This is the normal salary. Do you remember the normal value is going to be between 0 and 1, right? If you sort it from 0 to 1. So employee, the first employee, or this employee, is not the first because we did. This employee has a salary of 55,000, which is the normal value, which is the lowest. Look, this guy has the highest salary, which is 1. His salary is 88. Let's do the same thing for the GPA. So I'm going carefully. Either you repeat this or you do this, but change the normal salary to be GPA. Salary is going to be GPA. Why GPA here, small letter, Y here, big caps? This is already in my data frame. This is a variable in my data frame. It's defined as GPA with caps letter. This is a new variable I am adding called normal under GPA. I'm adding the letter. I'm adding any variable in a way that I would like to write it. This is just for you. I do not do this normally, but just for you to understand the difference. GPA. Again, get this guy. Here we go. Again, the GPA is the same thing. This guy has the lowest. GPA is not the lowest. For instance, we can now repeat Manhattan and Euclidean distances, but using the z values or the. So if I go to the Euclidean and Manhattan, let me copy these and find the distances. Find the distances using the standardized values. Then you can do the comparison yourself. But now you have to be careful. This is Euclidean distance z. I'm adding the z, right? Because this is standardized. So this is underscore z. Also, going to find the distance between what and what. Not my data. I'm going to choose the columns now. What columns I'm going to use? I'm going to find the distance between. I'm going to use the distance between the z salary, the z GPA. At the beginning, if you remember, before we had only these two. So we found the distance between this guy and this guy. So that's why I used my data. But now because I have many columns, I would like to find the distance only between these two columns. So it's not going to be my data, it's going to be inside a vector, my data, z salary, comma, my data, z GPA. So I would like to find the distance between these two variables only. The method Euclidean, then that's it. So these are the distances for the standardized salary and standardized GPA. Repeat this, but, I already have it here. Repeat this, but doing what? Manhattan distance. Manhattan distance using between standardized values. Manhattan distances between standardized values. So this is going to be here. Between the z salary, standardized z salary, standardized salary, and standardized GPA. So let me run this. So these are the distances among the standardized values. Then do the comparison. Look at the lowest, look at the highest. Look at the observations who are similar, the observations who are not similar, or dissimilar, or has the highest dissimilarity number, and so on. So this is everything about the similarity measures. I will skip the part of finding the similarity measures for the categorical, the matching, and Jacquard's coefficients. You can do this manually without getting into more complicated R scripts here. Thank you.